Hello everyone, welcome back to the channel. So in the last few videos, we have talked about concepts like caching, load balancing and resilience. But today we are going to discuss something that's used by some of the biggest technologies companies in the world, be it Netflix, Uber, Amazon and LinkedIn. And that's the event-driven architecture. Now, if you have ever searched for this topic online, you have probably seen complicated diagrams with Kafka, producers, consumers, topics, or even a lot more. And honestly, that can make it feel much harder than it actually is because at its core, event driven architecture is based upon on one simple idea. Instead of asking another service what to do something, a service simply announces that something has happened. And once you understand that idea behind the concept, you will start seeing it everywhere in the modern system architecture. So let's build this concept from the scratch. So let's imagine you are building an e-commerce application. A customer places an order. The order service calls the payment service and the payment service processes the payment. Then it calls the email service to send a confirmation email. Simple, right? Easy to understand. And honestly, for small systems, this works perfectly fine because every service directly talks to the next service. Nothing fancy. What's the problem in this? Now, imagine the business starts growing. The company wants analytics, rewards, fraud detection, shipping, recommendation system, and a lot more. Suddenly, the flow starts growing. Example, in the flow, I now add analytics service and reward service as well. And what happens eventually? The services start talking to each other. So my order service can directly talk with the email service, or it can directly talk to the analytics service or the reward service, right? And any service can talk to multiple services. Now we have a problem. Dependencies are everywhere in the code. A small change in one service can affect many others. Testing becomes harder, deployments become riskier, and understanding the system becomes more difficult. This is one of the biggest challenges in the distributed systems. Thinking differently would be now let's change our mindset completely. Okay. Instead of asking another service to do something, what if a service simply announced that something has happened? For an example, the event bus architecture, the event driven. For an example, instead of calling payment service directly, order service publishes an event, order created. That's it. Not a request, not a command, just a fact. A customer placed an order. The service simply announces it, right? Now, where does that event go? It gets published to something called an event bus. Think of the event bus as a central communication channel. Services publish events there. Other service listens from there. Popular technologies like Kafka are commonly used for this purpose. But for now, just think of it as a place where events are shared. Now, things get interesting. Multiple services can react to the same event, right? Payment service sees the event, email service also sees the event, analytics service and other services as well sees the same event. So each service perform its own task, and there's the important part. The order service does not know any of them. It simply publishes the event and move on. This creates something called loose coupling. Services become independent, and independence is one of the most valuable things in large scale architecture. Let's make this more realistic, right? Let's imagine you are opening an Uber application. You click book ride. What happens next? A lot of things, right? Driver needs to be assigned, fare needs to be calculated, notifications needs to be sent, fraud checks may run in the background. So instead of a ride service calling all of these systems directly, it publishes a ride booked event, and that event is something like this only. It comes to the event bus, and from the event bus every other services, the downstream listens to that event, right? Now, what happens in a failure scenario? Imagine email service crashes. So, this service gets crash. Does the order fail or does the analytics fail? No, it still processes it. Only one consumer has been failed. The entire workflow didn't collapse. This is one of the biggest advantage of an event-driven system. Failures become isolated in one place itself. Now imagine the business wants to introduce a recommendation service. The traditional architecture, someone needs to modify the existing service. The event driven architecture. The new service simply subscribes to an event like this. So, no changes to the order service, no changes to the payment, nothing changes to the email or analytics. The new service simply starts listening to the event using the event bus. This makes the system easier to evolve over time. So you might be thinking there might be some trade offs as well. Of course, no architecture is perfect. Event driven systems have challenges too. So you might be thinking there would be some trade offs, right? Of course, no architecture is perfect. Event driven systems have challenges too. Debugging can become harder, events may arrive out of order. Tracking a business flow across multiple services can be difficult at times. That's why event driven architecture isn't always the right answer. For a smaller application based upon your use case, where the direct communication is often simpler, we choose normal architecture, not an event driven architecture at that point of time. But as system grows larger, the benefits becomes much more valuable when you use an event driven architecture. So it's the thought of a system architect what to use based on your use case. So our final big pictures look like this. That's the service communicates through events basically, and the system becomes more scalable, more resilient, and easier to evolve. So, what real mindset you should keep? The traditional system focuses on request, be it service A to service B, a simple request. But an event driven system focuses on facts. Instead of asking another service to do something, a service simply announces that something happened and everyone else reacts. The small shift in thinking is one of the most important ideas behind modern software architecture. So, next time you hear someone talking about Kafka, events, producers, or consumers, remember that the real idea is actually very simple. Services publish facts, other services reacts, and that's the foundation of event-driven architecture. If you enjoyed this video, consider subscribing. I'll keep breaking down software architecture concepts in a practical and beginner-friendly way. See you in the next one.